Thanks everybody for coming. Good morning, good afternoon. It's not morning. It hasn't been morning in a while, but as you can see, there's no windows in this room, so I have no idea what time it is. Anyways, I'm glad to see you all. My name is Laura Thorson. I'm a program manager at GitHub on the DevRel team. I'm glad to have you all here. Friendly reminder to please silence your phones if you can. We will do Q&A at the end if we've got time. We're expecting to have a little bit of time to do that, so I'll be running a microphone. If you have a question, just put your hand up and I'll come find you. Otherwise, we're going to kick it off, and please give a warm, friendly welcome to John, and he'll intro you all to everybody else.
Thank you. Thanks for coming today. We're glad you're here. We're certainly glad to be here. This gentleman over here is Michael Rekachinas, and here we have Joseph Katsioludis. I'm John Rees, and today we're going to talk to you about how GitHub securely uses GitHub. The three of us are all members of the security team, but we work in different areas. And so the parts of GitHub that we use to affect security are also different. And therefore, our talk is broken up in that same way. And I'm going to start with my section, which is enterprise security. As I've said, I'm John Rees, but my real name is Jar349. I'm a staff engineer with the Secure Access Engineering team. Our responsibility is to secure the infrastructure on which GitHub runs, the data it contains, and to provide secure access to those things. I'm going to begin today by repeating something I'm sure you've already heard a lot. As far as possible, we use GitHub to build GitHub. And what makes that interesting is the fact that my team doesn't directly develop the product you know of as GitHub. From my team's perspective, that makes us very similar to you. We're using GitHub's security tooling to configure it for our security needs, just like you are. And so, to that end, I'm not here to blow your mind with the wild suggestion that you organize your enterprise, control its access, and keep it clean. I thought I'd share a few things that we do in the hope that it leads you to a more secure outcome. So let's begin. Let's talk about organization. GitHub has an enterprise on github.com. And inside of that enterprise, we have a number of organizations, including our main organization, GitHub. The reason that we separate things out that way is so that we can apply a different set of policies, settings, and requirements. That's in line with the best practices that you can find in our documentation. And in fact, I've pulled this quote directly from that documentation. Now, one of the interesting settings that we use is to control which organizations can have outside collaborators. An outside collaborator is a person who is not a member of your org, but does have access to one or more of your private repos. Users of GitHub Enterprise Cloud can restrict the ability to invite collaborators to an organization. And that's precisely what we do for the GitHub org within our GitHub Enterprise. For that org, only members can access the private repos. And when we have a set of repos or discussions or project boards where we want to encourage the participation from members of the community, we place those items into an org whose policies permit the presence of outside collaborators. And so, with our main GitHub org denied to outside collaborators, that means that everyone left is a member of the org. And we have a number of policies that we set in that org. Authentication has to happen with our SSO provider. 2FA is obviously required for all members. And since we control the members of our org through our open source entitlement system, we have some really strong guarantees that we know who is in our org and who is accessing it. A quick side note about entitlements, since I mentioned it. Entitlements is an open source access control system that was written by my team, Secure Access Engineering. It's a code as config approach to access control. It configures our LDAP cluster. And that's one of the reasons why we encourage repo access by team and not by individual. Entitlements manages the members of our teams on github.com, and it's those teams that get assigned access to repos. And that's also the reason why we disable outside collaborators in our main org, is because entitlements doesn't control outside collaborators. But now, we're starting to get into access control. So let's talk about that a bit. I just talked about entitlements and teams and repo access and all of that, but there's another way to access GitHub, personal access tokens, or PATs. A year ago, we released fine-grained tokens, and while it's still technically a beta release, we've been using them since its inception, and I recommend that you look into them too. Remember that a PAT, a legacy PAT, is basically a password, except it doesn't have to expire. It skips your MFA requirements, and it's among the more commonly leaked credentials that we see. Seriously, if you do nothing more when you go back home than to make sure that your PATs expire on a regular cadence, the savings from the detections, the investigations, and the remediations that you won't have to perform will have paid for your ticket here. And if the thought of your PATs expiring every 30 to 90 days gives you pain, it gave us pain too. But I'll remind you that the things that you do often tend to be the things that you do well. Okay, sorry, let me climb off that soapbox so I can tell you about another thing that we try to keep a tight hold on, which is org admins. Org admins have a lot of privileges, and so we have found that it's really just best to have none. None, at least, until the very moment those privileges are needed. We wrote a custom, in-house, just-in-time access provisioning system so that we can give ourselves sensitive and administrative access exactly when we need it, and then have it taken away when we're done. We use JIT to protect all kinds of things, and if you don't have a privileged identity management system, that's okay. My point here isn't that you need one, it's that we think that fewer admins is better. So take a long, hard look at yours. It just so happens that because we use JIT, our only org admins usually are the bot accounts that we use for automation, like JIT itself. Finally, a word about repos, branches, and actions. I've already spoken about how we prefer to assign repos to teams, but I want to remind you that actions permissions come from repo permissions. Now, due to the fact that we have turned off outside collaborators for our main org, we have control of team memberships, we force our org members to authenticate with our SSO provider, and that has to include 2FA, we pretty much give read access out like candy. We're much more wary of giving out write access. But that's not to say that we don't hand it out. GitHub.com is still mostly a Rails monolith, and the entire engineering team needs write access to that repo. So what do we do in cases like that? We use our branch protection rules. And we have a number of CI checks that run against all of our PRs. The result is that even though you might have write access to the repo, it's going to be really difficult for you to edit an action, to exfiltrate a secret without someone noticing in that PR review or running afoul of a CI check. And it is only those things. It is only through a PR that your code gets onto the main branch thanks to our branch protection rules. So look into setting up yours. And since I just mentioned exfiltrating secrets, let's talk about secrets a bit. We have a lot of secrets. I assume that we all have a lot of secrets to manage. We keep ours in a HashiCorp Vault cluster. We've designed it so that each app or service or repo or thing gets its own little enclave in Vault, and each enclave has its own access control list. This is also tied to our entitlement system, and it does still require 2FA. When we first introduced actions and repo secrets and org secrets, we had problems with the fact that secrets on GitHub are write-only. One of the difficulties of storing secrets into a write-only system is that when you encounter a leaked credential, it can be difficult to determine which of your secrets may have been using that credential. And for a while, we tried asking everyone to put their secrets into Vault, and then also put it into github.com with the same key and into Azure Key Vault with the same key, and you know exactly how that went. So we knew we had to do something. So my compatriots, Keith Markham and Stephen Hossam, came up with a system that they call Secrets Federation. New secrets now go in Vault, Vault only. And the Federation service gets configured to sync those secrets to the appropriate places. In the event that we want to rotate a secret, we now have one place to do it. And we're really confident that we rotated it everywhere that uses it. Now, while Vault provides both read and write capabilities, one of the things we're working on right now is to make the default access pattern for Vault be write only. And we will still provide read, but only when it's necessary for things like rolling a credential. Once we have this in place, a single person is going to be able to generate a secret. The whole company is going to be able to securely use it by adding some configuration. The security team is going to be able to rotate it in one place and have confidence that those changes will propagate to where they need to go. And the only person who's going to ever see the value of that secret is the person who generated it. That's good. As someone who has been woken up in the middle of the night and asked to rotate a secret, this makes me so happy, so happy. In fact, I just want to say it again. I'm going to say it again. A single person is going to generate a secret and put it into Vault. And the whole company is going to securely use it wherever they need it. The security team can rotate it everywhere by changing it in one place, and the only person who's going to see it is the one who generated it. That's cool. But you know what's even better? Not storing a secret at all. In many cases, we encourage the use of OIDC to retrieve assigned JWT, and we use that to authenticate to our secret stores to pull out a secret just as they need it, instead of syncing that secret to yet another store. This can be especially useful in cases where secrets consumers don't have direct network access to the secret stores. And by direct network access, I mean you probably don't want to expose your secret store to the internet, but you might be willing to expose a gateway. And OIDC is a great way to authenticate your secret store without having to expose it. Now, I do want to point out that all of this is for machine secrets, secrets that apps use. We do have another secret store for secrets that humans use, but that's not part of the scope of this talk. So, that's it for me. I hope you found some of those things interesting. And now, here's Michael Rekachinas.
Thanks, John. Hey, everyone. I'm Michael Rekachinas, sorry. And I'm a staff engineer in GitHub's product security. In product security, we focus on empowering engineers to design and build secure products. And we do this through activities like threat modeling, architecture and security reviews, incident response, bug bounty, and my team, which focuses on building framework-level paved paths and rolling out security tooling at scale across our thousands of repositories. And so today, I'm going to talk to you a bit about how GitHub secures GitHub with GitHub Advanced Security, because we consider GitHub Advanced Security to be a core pillar of our AppSec program. So what is GitHub Advanced Security, or GAS? There were several great talks this week that I hope you were able to check out. But in the meantime, this slide isn't comprehensive, but GAS covers tooling for supply chain security with Dependabot and advisory database, static analysis tooling like code scanning with CodeQL, secret scanning, and repo level security like what John mentioned earlier. So why do we rely on GitHub Advanced Security? We have a vast ecosystem. We have a lot of teams, a lot of projects, and a lot of repositories. We only have a finite number of security people. So traditionally, every project, every service, every PR might require some very intense manual security reviews. That's expensive and obviously doesn't scale. So the solution for us has been GitHub Advanced Security. Features like CodeQL and secret scanning allow us to identify vulnerabilities from the first line of code. And so the benefits there are scalability, right? GitHub Advanced Security scales effortlessly. It also gives us an efficient prioritization and execution of our security reviews. So aside from supporting security reviews, and aside from helping push left, why else do we think it's important? Let's again talk about secrets for a bit. It seems like every other day, there's a news story about a breach due to a stolen secret or password. According to the FIDO Alliance, 80% of data breaches are because of passwords. According to IBM, in 2023, the cost of a data breach for a company is about $4.45 million. You might have also heard, so far in 2023, that over 30,000 secret leaks have been prevented by GitHub Advanced Security's push protection. Additionally, 1 million secret scanning alerts have been dismissed, or resolved, right? So we've seen a bit about the power of secret scanning and push protection firsthand in product security. So John told you a bit about Secrets Federation, which will certainly help us keep clean going forward. But what if you aren't clean now? How do you get clean? And so it's funny I should ask. I led a company-wide effort to burn down all secret scanning alerts, and we had a lot. This is inevitable for a company that has 15 years of really rich history, thousands of services, prototypes and everything, right? We had to put in place a governance program to tackle this. So how did we run this company-wide effort? We couldn't have done it without GitHub Advanced Security. We knew right off the bat we needed to close as many alerts as we could to avoid overwhelming folks. We wanted to fan it out, but we couldn't do it initially. We had to close as many as we could. We also knew that we needed to focus on closing alerts that were either false positives or for already revoked tokens. GAS let us do that. The precise pattern matching and validity checks helped us close a bunch right off the bat. And then metadata about GitHub Pats in particular helped us identify the owners of particular tokens right away. We didn't have to go chasing people, go down rabbit holes and everything. So once the engineers did get this fan out, we asked folks to revoke and dismiss the alerts, and then provide the context of that disposition directly in the dismissal reason. So I don't show it here, but if you click false positive, it'll show a comment box, and you can put, or revoked. I revoked this and rolled the token, right? So all of that's important for setting up an audit trail if there ever is a secret leak. And so we were able to keep everything within engineers' workflows, which is a core pillar for us. GAS's API also made it easy for us to integrate secret scanning metrics, among others like code scanning and Dependabot, into our existing business processes. For example, we have an internal business system for running governance, tracking, and ownership of our existing services. We call it Service Catalog. You probably have one too. Our Service Catalog holds the scorecards for fundamental requirements of projects at our company. And this includes fundamental requirements like web performance, accessibility, availability, as well as everything under the umbrella of security. And so this gives engineers and leadership alike a holistic sense of the health of their respective service. And I also want to point out, the folks over at Security Overview took notice. And at Universe this week, they actually announced a dashboard that a totally new dashboard experience that will mean for us that for some things we may not need to even use our internal tool. We can use that new rich dashboard experience. They can see directly in the product, directly in their workflows, everything about what they own, which we think is pretty awesome as well. And by the way, this is still true today, that we're at 100% compliance with having secret scanning turned on and no alerts. And we attribute that to push protection. So I've given you an example of how integral GAS is for both security and engineers alike. But unfortunately, as we all know, security isn't just about the tooling. So the tooling's necessary, but by itself, it can't hold people accountable. So to keep people accountable, we have a program at GitHub called Fundamentals. Fundamentals is our internal program where we enforce adherence to those requirements I just mentioned. We do this through a monthly meeting where company leadership is briefed on trends as seen in our service catalog. And so in the case of our secret scanning alert burn down, this gave us the necessary accountability we needed for things like SLA management, being able to resource accordingly, meet internal and stakeholder needs, meet customer expectations, and in the case of the burn down, get to zero. So in summary, we found that the ingredients for successfully scaling security with GAS included, and it's not actually on this slide, but GAS. We had to have awesome tooling, right? That's the critical starting point, the critical piece. And then beyond that, the more human aspects of it. You need durable ownership. You need a way to identify who's responsible, and we do that through service catalog. You need accountability. That's, how do we ensure people are actually doing what we're asking them to? And so we get that through our fundamentals program. We decided to do a phased rollout, and we think that was a key piece of our success because we started with a pilot phase. We started with ourselves. What friction did we experience? At GitHub, we say ship to learn, right? Iterate, apply those lessons learned. And then lastly, critically, empathy, right? This is interrupt-driven work. Everyone's busy. Engineers are busy. Security's busy. We wanted to minimize disruptions and provide very rich support. And so we provided guidance, FAQs, support channels, live pairing sessions, hopping on calls with people. And so with GAS and these 4 practices, we were able to foster a security-first culture and get to and stay at 0 secret scanning alerts. So with that, I'll now pass it to Joseph.
Thanks, Michael. Hi, everybody. My name is Joseph, and I'm part of the GitHub Security Lab, a team of security experts with the mission to inspire the community to secure the open source software we all depend on. We are doing this mainly through 3 activities. First, by discovering vulnerabilities in critical open source projects. Secondly, by curating the GitHub advisory database, which fuels Dependabot. And third, by discovering novel vulnerability types and classes so that we hack the unhackable. In the same way we share this research with the community, we also share this research internally so that GitHub secures GitHub. When we speak about dependencies, someone can think about Dependabot. But of course, we can also have to think about GitHub Actions. We use GitHub Actions extensively to build GitHub, and of course, to automate a lot of things around that. When it comes to GitHub Actions, we are going to touch on this session today on how we verify these actions and what are the policies before we consume them. But before that, let's first understand what can go wrong, and of course, the impact of that going wrong. GitHub Actions eventually come down to code. Code can suffer from security issues. Due to the nature of GitHub Actions, we can have injection flows, in this case, template injections, and command injections. But of course, pull requests, because we are talking about GitHub Actions. That also depend on other code, therefore you have a whole supply chain issue right there. And on the bottom right, you see the word other with a question mark. Why? Because every single year, we discover novel ways to attack CI/CD pipelines. We don't know what we don't know, but what we can do today is to follow best practices so that we mitigate that internally. And this is exactly what we do at GitHub. What is the impact? The impact is highly correlated with the amount of permissions someone has in the GitHub Actions and the workflows. Give write access, and you give the keys of the kingdom. Someone can have access to every single secret, of course, access to push malicious code, and finally, access to change your releases. With read access, it's still possible to achieve secrets exfiltration, and of course, if you have self-hosted runners, someone can achieve persistence and lateral movements in the local infrastructure. We came up with a universe theme acronym that we called SPACE. S stands for secrets, permissions, actions, code, and runners. We stretched that a bit with the word ephemeral runners just to have the finally and come down to space. Let's start by each letter, starting from secrets. You should register all your secrets. If you're having hard-coded credentials, it's a very good time to pause the session and come back later. A trend we see is that a lot of people are registering the top-level credentials they have, like, for example, private keys. But in reality, you should also protect and register in the exact same way the intermediate credentials. Let's take the example of a JWT token that is signed by a private key. A private key at the top signs a JWT in the middle. You should protect both credentials in the same way they are both critical. When it comes to secrets hygiene, John touched on expiration, on rotating the secrets, so that if they do get compromised, you have them rotated. Least privilege principle is something we suggest strongly, so that you assume worst-case scenarios. If a secret is compromised, the worst that can happen is the least possible scenario. And an example of how you can do that is through giving the right access. For instance, imagine that you can have secrets at the org level, where somebody or everybody in the org has access into them, or even at the repo level, where you give secret access to everybody at the same repo. Well, you can segregate, you can dissect those secrets into environments, like the development environment and the production environment. Let's now go to the second letter, P, for permissions. When it comes to running your workflows, we suggest the middle option there, which is the read repository contents and package permissions, so that you avoid the read and write access, because we just discussed how bad the write access is and what can go wrong there. For this purpose, our colleague at the lab, Yaroslav Lobachevsky, has created this GitHub action, which is called Actions Permissions. Right now, we have staff shipped that, and we have the vision to introduce it publicly. And let's understand how it works. It's another GitHub action. You can enable it in your workflow, at the beginning of your workflow, and at the end. The goal of this action is to understand and give you a report about the minimum level of privilege that you can run your workflow with. After you have this report, you can push it in YAML so that it overrides the current permissions you have. And of course, this ensures that you follow the principle of the least privilege. Let's move now to A. This slide captures the internal GitHub policy when it comes to GitHub Actions. We strongly recommend that you follow a very similar policy to us. let's explore our policy. First, we are using trusted actions only that come from GitHub or third-party or GitHub partners that we trust. We are pinning the versions by using the SHA hash there, so that when an action is compromised or is updated, we don't have the action pointing directly to the updated version, but we know exactly which version we are pointing to. So when we want to upgrade, we just change the SHA hash there. Finally, when it comes to third-party actions, we follow the motto of trusting but verify. Let's understand what it means to trust but verify. We had an internal effort where we wanted to understand what third-party actions are used internally. And once we were done with that, we decided to scan the code of those actions to point out potential vulnerabilities. We did that through CodeQL. CodeQL stands for Code Query Language, is our SAST tool, is the machine behind GitHub Advanced Security. CodeQL has queries that point directly into vulnerabilities. What we did was that we used the multi-repository variant analysis, or MERVA feature, where we picked a query, let's say a query that finds out about injection vulnerabilities, and we run it in every single third-party action that we consume internally. So we run in parallel all the third-party actions to discover problems into those. And after doing that, we work directly with the maintainers to fix those issues. Let's now move into C, the penultimate letter. GitHub Actions is code, OK? When you have code, you might have user-supplied input. It's very dangerous if you supply this input directly into the run or script steps, because you give arbitrary code execution to a malicious third party. Let's pause for a moment and understand that a branch name or a pull request title or a pull request body are user-supplied data. And we have seen in the past those being maliciously used in order to execute scripts. Like, for instance, an example where someone managed to interpolate Maven and run malicious scripts. If you do have to use user-supplied input, make sure that you use intermediate environment variables to host that in, so that you sanitize it and you use the input. Friends don't let non-friends run their actions. The default policy is to require approval for first-time contributors. But it's very easy for someone to become a non-first-time contributor, a frequent one, by fixing typos or minor issues. Well, that's fantastic to get started in open source. We highly encourage that. But when it comes to security, we recommend to require approval for all outside collaborators. Finally, we have runners. Our internal choice is cloud-based runners. And this is because they are ephemeral. They are also isolated. Their life is going to have an end at some point. So if they do get compromised, this level of compromise is going to get expired. When we have to use self-hosted runners, of course, we make sure that they are configured to the absolute best state of the art. But again, remember that self-hosted runners have the chance to have persistence when they get compromised, and the chance for someone, since they are already in your local infrastructure, to move laterally in other parts of that. Just before moving to questions, there is a session survey on the attendee portal about this session. If you learned something new today, let us know. Let us also know how to improve. I would like to thank you on behalf of the three of us. And we have 5 minutes for questions. Thank you.
Hi. The two tools that you mentioned earlier for secret syncing and the other one for just in time, are they open source?
They are not open source.
Can they
No.
be?
Can they be? Excellent question. When I designed JIT, I intentionally did not make it super tied to GitHub things with the thought in mind that it may be possible in the future to open source. So I had that in my head, but at the moment, I'm afraid to say that we don't have plans to open source JIT. But if you have interesting like JIT requirements or JIT questions, I'd be happy to talk to you about those after.
Thank you.
Yes, sir.
Hey, so we were actually very interested in the secret rotations and going into GitHub, and I keep running into the roadblocks of only being able to really refresh tokens via the web interface. I guess Vault kind of does it do its own thing of calling into the API to rotate it, or is there other ways? Are you using Git apps to rotate it?
Are you asking about how we actually take what's in Vault and get it out to the other locations?
Yeah, I like to refresh it within
Yeah.
GitHub itself.
Yeah, we do have a separate internal service that we authored that pulses these things out on a cadence. And so we're just overwriting all the time. It's idempotent.
Can that be open source?
I did not write or design Secrets Federation, and so I don't know whether or not that is really tightly integrated with our internal stuff or not. But what I can do is get you an answer on that.
Sounds like you've got customers that have desires here.
Yeah, yeah.
For GitHub Cloud, personal access tokens is a big pain in the ass. Is there a potential feature request that is out there for being able to mandate that people who you can't see how old their key is must rotate it within a certain boundary?
That would be the identity team. Yeah, we can look into that and definitely see about.
Yeah, unfortunately, you've asked a security product, and I work on the infrastructure security bit, so I can get you an answer, but I don't have it.
We have an internal process that does audit DATs across the enterprise and force users to rotate them every 90 days. So there is ways that you could use the management console
Yeah,
to enforce that. So it's like a GHE command to collect all that information.
he's right back there.
We do it at GitHub too.
It's self-hosted.
Yeah, cloud sucks because you can make their own accounts, you can't make them.
That's interesting.
Yeah.
I want to know about that myself. I'd like to talk to you about that. Any other questions?
Have you thought about things like push protection for your code example for actions, where you're inlining branch names, possibly malicious code?
I personally haven't thought about that. It's a great idea. Is this something you are working on?
We don't use that exact implementation, but similar implementations in some workflows that we have.
Does this exist or?
I don't know.
Yeah, same.
Sorry.
Let's discuss in more detail. Great idea.
I think this will be the last question.
Earlier, you mentioned you use OIDC for to connect to your cloud resources. How do you enforce that, and do you monitor that in the actions to make sure that users are following those best practices?
Oh, okay. So to be clear, you're talking about how are we making sure Like, what is it in your mind that you think we need to be protecting that we're not
So let's say as
protecting?
part of my workflow, I'm deploying to AWS.
Yeah,
and
sure.
So to connect to that, I'm not using access keys, so forth. So we're requiring them to use OIDC, right? And so we have a process that we go through and monitor the workflow logs for that. But the workflow logs are very unstructured, and it's kind of hard for us to look for those things. I wonder if you guys have something similar where that you're monitoring, or if there's a better way to access the actions workflow logs to monitor those kinds of activities.
Right, okay. So first of all, what I'm hearing is that we need to improve our workflow logs to make it easier for you to find this stuff. So
Yeah.
whoever's out there.
Note for the actions team.
And then the other thing is that our focus is in not putting them there to begin with through like push protections and the code reviews and that sort of thing. So in fact, we have, oh crap, we have, we work hard to like blank out any passwords we see in any sort of log stuff so that it never actually reaches like log backend storage too on top of that. And so if you're having trouble like parsing logs, then that's a thing then we need to improve for you so that you can do the same or similar things.
Yeah, well, we keep our secrets in vault actually as well.
Cool.
But we want to enforce OIDC policy as opposed to using access keys, passwords, and things like that. So,
You're back on mic.
should I repeat?
It's fine. I think we got to wrap it up. We're all set here. Yeah. You want to give them all a round of applause? Thank you.